Alright, so last night what I had asked everyone to do was on page 418, I had asked everyone to please do numbers 9 and 13 to 19 odd. That was your homework. So right now let's take a look and see how you did. So on page 418, taking a look at number 9. Problem number 9, it says find the sine of 2x minus the sine of x is equal to 0. We want to try to solve that. So this is just the formula 2 sine x, cosine of x minus the sine of x is equal to 0. If we factor out a sine of x, we get 2 cosine of x minus 1 equals 0. Well, when is the sine equal to 0? That would happen at 0 radians and at pi radians. And it asks us between 0 and 2 pi, so that would be the answer for that. And for this part, 2 cosine of x minus 1 equals 0, or when's cosine equal to 1/2. That comes from our 30, 60, 90 triangle. Forgive my triangle is awful. It's a little bit better. And the cosine of 60 is 1/2. So 60 degrees, and if all students take calculus, it would also work over here at 300. So x would be 60 degrees, which is just pi over 3. And x would also be 300 degrees, which is, convert that real quick here, 300 over 180 is 5 pi over 3. Okay, so those are the answers for number 9. Let's take a look at number 13. Number 13, it's telling us to find the cosine of 2x plus the cosine of x is equal to 0. So I would prefer to have all the same trig functions, so I'm just going to convert this to the one using cosine. 2 cosine squared of x minus 1 plus the cosine of x is equal to 0. This is really just a trinomial. And if we factor using the AC method, you have to get positive 1, so this is going to be positive and negative. So if we make this equal to 0, when is cosine equal to 1/2? Well, we had just seen that in the previous problem, right? So it would be 1/2 at 60 degrees and at 300. And if we convert, it wouldn't be 300. If we convert 60 degrees, that's pi over 3. If we convert 300 degrees, that would be 5 pi over 3. And then when is cosine of x equal to -1? It's a quadrantal angle. Cosine's the x value right here at pi radians. So those should be the 3 answers for number 13. All right, number 15. Number 15, it says, oh good, we have the sine of 4x is equal to -2 times the sine of 2x. Well, we saw in the notes that we could write the sine of 4x as 2x plus 2x. And this is just a double angle formula. Sine of 2x would be 2 times the sine of x cosine of x. So using the sum and difference formula, this would be the sine of 2x, cosine of 2x, or I'm sorry, yeah, no, that's right. And then same sign, cosine of 2x, sine of 2x. Equals -4 sine of x cosine of x. All right, so let's see what happens over here. I'll just put the book down, roll up my sleeve, and this would be 2 times the sine of 2x cosine of 2x. And eventually we're going to have to bring this part over, so 4 sine of x cosine of x. All right, well this part's easy. This would be 2 times It doesn't want to erase. All right. 2 times 2 sine of x cosine of x. And the cosine of 2x, I have a few different options. I don't really see any preferred way, so I'm just going to use the first way. That would be cosine squared of x minus sine squared of x. And let's see if we could simplify this. This would be 4 sine of x cosine of x, which we'll have to distribute in. Okay, so if we do that, we're going to get 4 sine of x cosine cubed of x minus 4 sine of x, or actually 4 sine cubed of x cosine of x. So it's not hard math, it's just pretty long. Looking at everything, I could definitely take out a cosine of 4. Let me see here. I could actually take out a sine from everything. And I can take out a cosine. So let's see if that makes our life a little bit easier. We would get cosine squared of x minus sine squared of x plus 4 cosine of x equals 0. Oh, actually, this would just be... oh, wait a minute. I'm sorry, guys. We took out a 4 sine of x cosine of x, so that would just become 1. All right. So at this point, what we could do is I'm going to try to convert everything into... let's see, I'd really like this 1 to go away. Let's see what happens if I just convert this cosine squared to sine squared. Oh, shoot, guys, I'm sorry. So let's see here. We factored out a 4 sine cosine from everything. So this would just be plus 1 inside the parentheses. All right, so 1 minus sine squared is equal to cosine squared. So this is just 4 sine of x cosine x times cosine squared of x plus cosine squared of x, and that's equal to 0. All right, so now we're almost done. Okay, so when is 4 sine of x cosine of x equal to 0? Or if we divide by 4, well, when is sine of x 0? Well, sine of x is 0 at 0 and at pi radians. Okay, when is cosine of x 0? Cosine of x is 0, that's the x value, at pi over 2 and at 3 pi over 2. When is 2 cosine squared of x equal to 0? Or when is cosine squared of x 0? If we divide by 2, and if we take the square root, when's cosine of x equal to 0? We already did that. So those 4 answers should be the right answer. And this was for number 15. I'm just going to double check it in the back of the book here real quick. 418, number 15. So 0, pi over 2, pi, and 3 pi over 2. Okay, so that one's good. So a couple more to go. So that was number 15. So let's take a look at 17 and 19. A train's coming, you might hear it. Number 17, it says, use a double angle formula to rewrite the expression. Okay, so this one's going to be easy. 8 times the sine of x cosine of x. Well, I know sine of x cosine of x looks a lot like the sine of a double angle. So this would just be 4 times the sine of 2x. That one's pretty easy. And then number 19. Number 19 says 5 minus 10 sine squared of x. And if we take a 5 out, we get 1 minus 2 sine squared of x. And that should look familiar. That's just the formula for the cosine of a double angle. All right, so that's the homework review. A couple of them were a little bit tricky, but I hope you followed along. If you have any questions, you know to leave me a comment, or of course you could send me an email. Thank you so much. Have a nice day.